so let's start. So let's look at the first question, question number 32. This is lesson 11. Okay, the largest four-digit factor of 87878 is a prime number. What is it? So this includes two parts to solve this question. The first step is we have to prime factorize this 1, 2, 3, 4, 5-digit number, and then we need to determine if that four-digit factor is a prime number. Okay, so let's do the first step. That's going to be prime factorizing 87878. So 87878. I hope you still remember how to do prime factorization. Divide by 2. We start with the smallest prime number. Okay, and then this is 4. Then we have 7, so that's going to be 3. And then 18, so 9. And then 7 again, 3, and then 9. This is 18 again. Now, this is an odd number. We cannot divide by 2 anymore. So we have to move on to, let me just write down the prime numbers we have to try. We have 2, 3, 5, 7. These are all the prime numbers less than 10. And then it should suffice. So let's try. 2 cannot work over here. How about 3? We look at the digit sum. So 4 plus 3 is 7. 7 plus 9 is 16. 16 plus 3 is 19. And 19 plus 9 is 28. 28 is not a multiple of 3 because 3 times 9 is 27. So it's not divisible by 3. So the whole number is not divisible by 3. So no. And since it didn't end in 0 or 5, so the 5 is also not a factor. How about 7? Let's try 7. So 43939 divided by 7. Let's see if it is divisible. So first of all, the 43 divided by 7 is going to be 6. 42 goes over here with 1 remaining, and then the 9 comes down, and 2 times 7 is 14. Then it will give us 53. And then 7 times 7 is 49. Now 53 minus 49 will give us a 4 at the bottom, and then 9. The 9 comes down, so 7. 7 times 7 is 49. Okay, so it is divisible. Good. So that means we can write 7 over here, and then what goes below will be the quotient 6,277. Now the first step is complete. We need to move on to the second step to check if this four-digit number is a prime number or not. So is 6277 a prime number? So remember, in lesson 11, we taught about methods to identify if a number is a prime number or not. And that is, first, we look for the closest square number that is slightly larger than it. Okay? And in this case, it's 80 squared, which is 6,400. So you see it's slightly larger than 6,277, and it is a square number. So we take the square root, the 80, and we check for all the prime numbers less than the 80. So all the prime numbers up to 80, that's going to be 2, 3, 5, 7. And then, so starting from 2-digit prime numbers, remember all of them will end in either 1, 3, 7, or 9. So 11, 13, 17, or 19. Okay. So 11, 13, 17, 19. Yeah, these are all prime numbers. Let's keep going. 21 is not. How about 23? Yes, it is. 27 is not, but 29 is. Then 31, yes. 33, no. 37, yes. 39, no. 41, yes. 43, yes. 47, yes. 49, no. 49 is 7 times 7. And then we have 51, that's 17 times 3. 53 is, 57 is not, 59 is, and then 61, 63, it's not, 67, yes, 69, no, then 71, yes, 73, yes, 77, no, 79, yes. So these are all the prime numbers up to 80, and we need to divide 6,277 divide this number by all of these prime numbers to check if this four-digit factor is a prime number or not. And I won't go through it. I won't go through the details over here. But the answer is yes, this is a prime number. So the largest 4-digit factor of this of 87878 will be 6277. Okay, this is the answer. Let's keep going. Moving on to the next question. The product of 4 consecutive, so the product, we're doing multiplication over here, of 4 consecutive positive integers is 3024. What is the largest one among these 4 integers? So we will use an equation to solve this question by setting one of the numbers, one of the consecutive positive integers as x, and the others as x, either x plus 1 or x minus 1. And we need to set this x smartly. So the question is asking for the largest one among the 4 integers, 1, 2, 3, 4. So the largest one will be over here. Now we let the one we want, the largest one, to be x directly, so that when we solve for x, we will get our desired answer directly. So this one will be x minus 1, this one will be x minus 2, and this one will be x minus 3. And we look for the product of the 4 consecutive positive integers. Oh, sorry, we don't need to use equation. Sorry about that. We can just do prime factorization directly with the 3024. So 3024, do prime factorization, start with the smallest prime number 2, divide by 2, that's going to give us 1512. So still even, still divide by 2. This is 700 and, not 7, so 756. Still even, still divide by 2. So 378. Still even, still divide by 2. Then 184. Still divide by 2. This is going to give us 92. Oh, sorry. So let me just check if I did the calculation correct. Divide by 2. 1512, 756, 378. Oh, so it shouldn't be 184 over here. It should be 189. So be very careful with your division over here. And then we cannot divide by 2 anymore because it's odd, not even. And then let's check the digit sum to see if it's divisible by 3. So 1 plus 8 plus 9 is 18. It is divisible by 3. So divide by 3, that's going to give us 63. And then divide by 3 again. This is 21. And then divide by 3, 7. Let's check. That's correct. 189 divide by 3. Yes. 63 divide by 3, divide by 3. Yes. So we've done the prime factorization now. The 3024 equals to 2 to the power of 1, 2, 3, 4, power of 4, times 3 to the power of 3 times 7. Okay. Now we want to split these, okay, into 4 groups so that we will have 4 consecutive positive integers. Now 7, first of all, 7 must be one of those integers because if we have, let's say, 7 times 3, that's going to give us 21. And it will be too far away, right? And we want to keep these factors as 1-digit numbers by so far. Okay, so 7 will be one of them. And then let's see if we can have an 8. Yes, we can. We can have an 8, which is 2 to the power of 3. So 8. Now we have 2 and 3 to the power of 3 left. How about 9? Yes, we can have 9. 3 squared is 9. And now we have 2 and 3 left. So 2 times 3 gives us 6. Now we have our 4 integers, 6, 7, 8, and 9. If we multiply them, we will get 3024. And we are looking for the largest one among these 4. So the answer is 9. Okay, that's this problem. And then we can move on to the next one. Edward has a piece of paper which is 2002 millimeters wide and 847 millimeters long. After making one cut, he has 2 pieces, a square and another rectangle. He repeats the process with the new rectangle and continues until the very last 2 pieces are both squares. So let me just draw a rectangle first so that I can illustrate what this question is saying. So let's say we have this rectangle here with width 2002 millimeters and length 847 millimeters. And we make a cut, right? So we will have a square. Just get the straight line tool. Oh, I have the ruler over here. So we make a cut. I know it doesn't look like a square, but let's just say this is a square. Okay, so this will be 847. And then we have a square. And then what's left will be a rectangle with length 847, but with a different width this time. It's going to be 2002, take away 847. Now again, we make another cut. Let's get the ruler over here. We make another cut. And we get another square. This is 847. This is 847. And then what's left here will be, let's say we repeat this procedure until we get this length right here less than 847. That's when we throw away all the squares we have got, and we always focus with the new rectangle we get, right? Okay, so obviously 2 cuts is not enough. Let's see how many cuts can we make until we get this length less than 847. So we are going to do a division over here. 2002 divided by 847. Oh, actually it is 2, right? So 847 times 2, this is going to give us 2 times 7 is 14. Carry a 1. 2 times 4 is 8. 8 plus 1 is 9. 2 times 8 is 16. So it is 1,694. And we take that away from 2002 and see what's left. What's left will be this length. So take away this. 2 minus 4 is 8. Borrow 1. 9 minus 9 is 0. Borrow 1. 19 minus 16 is 3. So it's 308. So it's going to be 2 with a remainder of 308. And that means this length over here is 308. So right now we will discard the 2 squares we got because we only want to focus on the rectangle. Okay, so this is the rectangle we have, and we work with this one. So we make a cut. We want a square, which will be 308 times 308. Okay. And then a new rectangle we get will have a width of 308 and a length of 847 minus 308. This is 9, this is 3, this is 5. So 539. Right? And then we, again, erase the square we got because we don't want it anymore. Okay, this is the new rectangle again. Oh, this should be 539. We make a cut so that we will have a square again. This is 500, and actually we can do the division. Yeah, 847 divided by 308. It's going to give us a 2, and then 616. See what's the remainder. This is 1, this is 3, and this is 1. Oh, sorry, this is 2. So 231 will be the remainder. Okay, so that means this will be, let me just sort of raise this line over here. This will be the square. Get the ruler over here. This will be the new square. And then this length right here that's left will be 231. Then here, this is still 308. Right. Again, erase the square. We don't want the square. We only want the rectangle. So we make another cut. This is 231. And what's left? The new length, the new width right here, this really tiny length right here will be 308. Take away 231, which is 77. And for those who are number sensitive, this will be a good sign because 231 is a multiple of 77. Okay, this is 77 right here. Again, erase the square. Focus on the rectangle. So we have a rectangle that is 77 millimeters wide and 231 millimeters long. Okay, now we make another cut. So 231 equals to 77 times 3. We can split this whole thing into 3 equal squares. Now we make another cut. We get 177 times 77 square, okay? And then we erase that square because we always work with rectangles. And now we have this 77 times 154 rectangle. Now we make our final cut, and it's being cut into 2 equal squares. Okay, so I know it's a lot of cuts, but to summarize, it's basically just asking you to do some division and subtraction, right? So finally, we will have 2 squares. Sorry, doesn't look like 2 squares. So 2 squares with side length 77, which is exactly what the question is asking for. What is the length of a side of each of these final squares? 77 millimeters. Finished. That is question number 34. Let's keep going to question number 35. What is the number of zeros at the end of the product of, first of all, 1 times 2 times 3 times 4 times 5, and then 1 times all the way to 25. There's another fancy way of representing these multiplications. This is 5 factorial, and this is 25 factorial. So factorial basically means that we start from this number, we multiply all the consecutive integers all the way back to 1. Okay, that's the meaning of factorial, represented with 1 exclamation mark. Okay, so to find the number of zeros, we basically find the numbers of tens, right? So whatever number it is, the product, we don't care. We only care about how many tens we're multiplying. If we're multiplying with 1 10, we will have 1 0 at the end. If we're multiplying by 2 tens, in other words, 10 squared, we will have 2 zeros at the end. If we are multiplying by 10 cubed, we will have 3 zeros at the end, etc., etc. So we're basically just looking for 10. And if we split up 10, we are actually looking for 2 times 5, right? So how many 2s we have and how many 5 we have. Or sorry, it shouldn't be how many 2s and how many 5 separated. It should be how many 2 and 5 pairs do we have in this question. Let's say if we have 2 to the power of 3 times 5 to the power of 2, then we only have 2 pairs of 2 times 5, yeah? 2 to the power of 2 times 5 to the power of 2. So it's like the buckets. Do you still remember the buckets? Yeah. A bucket is made using different lengths of wood pieces. Let's just say this is the bucket. Now the minimum or the maximum volume of water I can fill into this bucket depends on the shortest wood I use, right? So it's similar to this question over here. The number of zeros I have at the end of the product depends on which is less, yeah, the least power I have. So in this case, it's squared, it's 2, so 2 to the power 2 squared times 5 squared. That means this is 10 squared, and we will have 2 zeros at the end of the product. So we can use this method and analyze for this question. For the first part, 5 factorial, so 1 times 2 times 3 times 4 times 5, we have 2. Right, I have to mention this again. I have to mention this before we look at these 2 questions. So that is, we want to, instead of looking for pairs of 2 times 5, we are actually looking for the number of 5, because we have abundant 2, we have excess 2, lots of 2, right? So this is 2, and this is 2 squared. So altogether we have 2 to the power of 4. We have 4 2s. So we have lots of 2s, but we have limited number of 5s. So just like the bucket theorem, we can just look for the number of 5. The number of 5 will determine how many groups of 2 times 5 we have, and that will determine how many tens we have. Okay, that will reduce our workload. We just look for the number of 5. We have 1 5 over here, and that means we only have 1 10. multiplying all the other numbers, that means we only have 1 0 at the end of the product. 1. And then for this one, how many 5s do we have? We have 5. We just look for the multiple of 5. So 5, 10, 15, 20, and 25. Okay. And then this is 5 times 1. This is 5 times 2. This is 5 times 3. This is 5 times 4. And this, pay attention, be careful here, is 5 times 5. Now let's count how many 5s do we have. 1, 2, circle them. 1, 2, 3, 4, 5, 6. So we have 6 5s, right? 5 to the power of 6. Now we will definitely have more than 6 2s, but because we only have 6 5s, so we will pick out 6 2s and make 6 pairs of 5 times 2, which will give us 6 10s. So 10 to the power of 6, that means we will have 6 zeros at the end of 25 factorial. Okay, so the answer for these two questions is 1 and 6. Let's keep going. Question number 36. On a snowy day, Pip and his father measure the circumference on a circular flower garden. They start at the same time from the same point next to the garden and walk towards the same direction. After walking for a whole lap, both of them were just returning at the starting point. Pip's step length is 54 centimeters and his father's step length is 72 centimeters. Since their footprints overlap, they leave 60 footprints in total and on the snow after walking one lap, and find the circumference of the circular flower garden. So this question is a typical type of question with tons of words, right? It's a very lengthy word problem. But if we extract the useful information, it is actually pretty simple. So it's basically Pip's step length. So for every step, Pip is covering 54 centimeters, and with every step, Pip's father is covering 72 centimeters. All right, so their footprints will overlap because 54 and 72 has a lowest common multiple, the LCM. On that lowest common multiple, the Pip's footstep will overlap with his father's footstep, right? And originally, we should count 2 footsteps, but because they're overlapping, they only count as 1. So 2 footsteps count as 1, right? That means, let's say, if, for example, it takes Pip 100, I will use a line segment to represent, that will be easier for you to see, but much clearly. So originally, let's say if it takes Pip 100 steps to cover the circumference, and it takes Pip's father 60 steps to cover the circumference of the flower garden, and this will be the overlapping part. And if we look for the sum of Pip's number of steps and Pip's father's number of steps, that's going to be, for Pip, that it will be 1 tick plus another tick, and for Pip's father, it will be 1 tick plus another tick. So you see, for the overlapping part, we are counting it twice. Yeah, we have 2 ticks, but we only want 1 tick. The whole thing is 60 steps, right? So ignore the imaginary number I used. I assume it's going to take Pip 100 and Pip's father 60, but this is definitely not the real answer, okay? Or in other words, let's say this is X and this is Y, okay? So for Pip, it's X, and for Pip's dad, it's Y. Now we know that X plus Y, X plus Y, take away the overlapping part once, will give us 60, right? And how do we find this X or Y? There is a way, and that is, we know one thing that's not changing, and that is the circumference of the circular flower garden. We can use this, set that as X. We can assume the circumference is X centimeters. Now it's going to take Pip X over 54 steps, right, to cover the circumference of the garden, and it's going to take Pip's father X over 72 steps to cover the circumference of the garden. We add them up, and then we take away the overlapping part. Now the overlapping part will be a little bit different. It's going to be more complicated. It will be X over the LCM of 54 and 72. That is, so let's first find the LCM of 54 and 72, and then I'll explain why. So 54 and 72, we do short division to quickly find the LCM. Divide by 2 first. They're both even. This is going to give us 27 and 36. They're not even. They're not both even anymore, but they're both multiples of 3. So divide by 3. This is 9. This is 12. Still divisible by 3. So we stick with 3 and divide. This is 3 and this is 4. And then we multiply everything on the outskirts of this short division. That will give us the LCM. So 2 times 3 to the power of 3 times 4. And that is 3 to the power of 3 is 27. 27 times 8 is 216. So 216 will be the LCM. The reason we want to take away x over 216 is because we know that for every 216 steps, the Pip's and his father's footstep will overlap, right? So that's gonna, so for the whole circumference, it will be x, the circumference of the garden, divided by 216 centimeters. Yeah, it's not 216 steps. It's for every 216 centimeters, Pip's footstep and his father's footstep will overlap, right? So the overlapping part will be x divided by 216. And we know that this is going to give us 60 steps. We can use this. We first make the denominators into the same denominator. Now, 216 is both a multiple of 54 and a multiple of 72. So we can easily find make them all into fractions with denominator 216. This is going to be 4x over 216 plus 3x over 216 minus x over 216 equals to 60. And we can multiply both sides with 216, and the denominators will be gone on the left-hand side. So 4x plus 3x minus x equals to 60 times 216. And then on the left-hand side, we have, let me just write over here, 6x equals to 60. On the right-hand side, we have 60 times 216. We can divide both sides of the equation by 6. That's going to give us x equals to, the 60 divided by 6 is 10 times 216. Now x equals to 216 times 10, which is 2,160 centimeters. So the answer is 2,160 centimeters. Or if you want to represent it with meters, which is a more common unit, so it will be 216 meters. Finished. That is this question. Okay, let's keep going. Give me a sec, everyone. Right, so question number 37. Place the numbers 1 to 9 inclusive once each in these gaps to make this multiplication correct. So first of all, with these type of problems, we should be proficient by now. We first prime factorize 5, 5, 6, 8. It's even, so we divide by 2. That's going to give us, this is 4, this is 7, this is 8, this is 2. And then, oh, sorry, not 4, it's 2. So 2, 7, 8, 2. Then divide by 2 again, it's still even. So it's 1, oh, sorry, we start with 2 over here. This is 1, this is 3, this is 9, this is 1. So I did the division wrong, didn't I? Yes, Mina?
It's meant to be 2784.
Yeah, 2784. Yeah, thank you very much. So 2784. Yeah, divide by 2, and that's going to give us 1392. So it's still even, still divide by 2. That's going to give us 691. And then, oh, sorry, 696. I'm doing these multiple divisions all wrong today. And then divide by 3. That's gonna give us 232. Oh, sorry, not yet. So still even, still divide by 2, and that's gonna give us 323. Divide by. Can we divide by 3? Oh, so this division is a bit annoying. Just check. 2784, that's correct. 1392, 6. So 3348. Sorry about that, everyone. It's been a long day. My brain is just not working anymore. and then still divide by 2. That's going to give us 174. Divide by 2 again. This is so 174. Yeah, that's correct. Then this is 89. And then divide by, can we divide by 3? Just give me a sec, everyone. I'm sure I can get this. Divide by 2, it's 174. It should be 87 over here. Right. And then we divide by 3 because its digit sum is 15. It's divisible by 3, and then it will give us 29. Right. Finally, done. This prime factorization. This 5568 equals to 2 to the power of 1, 2, 3, 4, 5, 6. 6 times 3 times 29. All right. And then we are trying to fill in these. We want to split these into 2 groups so that the product of each group will be able to fit into these boxes and to make this multiplication correct. So let's try 29. We have a 2-digit number over here. So let's try 29. The rest will be 2 to the power of 6 times 3. And it can be, so 2 to the power of 6 is, it's equivalent to 4 to the power of 3. This is middle school knowledge. You don't need to know this right now, but it's just simple to calculate. You can, of course, do 2 times 2 times 2 times 2 all the way to 6 2s. It's going to be 64. So 2 to the power of 6 is 64. 64 times 3 is, this is 2, and this is 192. So 192 times 29 will give us 5568, but that's not acceptable because we only want 1 to 9 inclusive ones each. So 29 won't work. How about 29 times 2? We pick out one of the 2. Yeah, that's going to give us 58. So 58, the rest will be 2 to the power of 5 times 3. This is 32. 32 times 3 is 96. So it works. Let's say this is 96 and this is 58. So 58 times 96 will give us 5568. And then we want a 2-digit number times a 3-digit number. Let's not multiply 2 this time. Let's multiply 3. This will give us 87 times 2 to the power of 6 is 64. So no, it won't give us a 3-digit number. And let's try a different direction. Let's formulate the 3-digit number with the 2 to the power of 6 times 3 over here. So 2 to the power of 6 will be, nope, 2 to the power of 6 will be 64. So it's still not enough. It will just be the beginning when we are doing 29 times 192. So no, let's do 29 times 2 times 3. What will that give us? So this is 87 times 2, which will be 174. Right, so far so good. Looks promising. The rest will be 2 to the power of 5, right? Because we took 1 2 and 1 3 away. This is going to give us 32. All right, so we got it. So 174 times 32. Done. 1 2 3 4 5 6 7 8 9. Right? 1 to 9 inclusive, ones each into all of these gaps. And correct multiplication, you can check and do the multiplication on your own and see if the product is 5568. Right, that's question number 37. Let's keep moving through lesson 12. This is the challenge question in lesson 12, autumn term. So I hope you still remember how to solve this. For those who are not comfortable with how to solve this, it's no problem at all. We will go through it again. So the figure below shows 9 circles and 6 lines. We need to find 9 consecutive whole numbers, include 6, to fill in each circle so that the sum of the numbers on each line equals to 23. So first of all, let's find how many line sum are we talking about? So one line sum, 2 line sums, 3 line sums, 4, 5, 6. So we're talking about 6 line sums. Okay, and just to save us some time, I will use K. small letter k to represent the line sum from now on. So 6k equals to how many times are we counting these circles? Let's count. Let's figure that out. So this is going to be 1, 2, 3 for this line. And then for this line, it's going to be 1, 2, 3. And then for this line, it's going to be 1, 2, 3. For this line, it's going to be 1, 2, 3. For this line, it will be 1, 2, 3. For this line, it will be 1, 2. Okay, so it looks like we are counting all of the circles twice, apart from the 6, equals to all other circles, right, times 2. I should probably write the sum. The sum of all other circles times 2 plus a 6 equals to 6k. And we know that the line sum is 23. So k equals to 23. This will be 6 times 23. Okay. And you see, we can easily find the sum of all other circles by doing 138, take away 6 first, and then divide by 2. This will be the sum of all other 8 whole numbers. Now we took away the 6, and we know the 6 is one of the 9 consecutive whole numbers, right? Let's find the sum, shall we? So the sum is 132 divided by 2 is 66, right? So that means apart from the 6, the sum of all the other 8 whole numbers will be 66, right? And if we add 6 to it, the 6 we didn't count, this will be the sum of the 9 consecutive whole numbers, which is 72. So 72 is the sum of the 9 consecutive whole numbers. And I hope you still remember this equation. So the sum divided by, or in other words, the median of a sequence times the number of terms, we use hashtag to represent number of terms, equals to the sum of all terms. So we make use of this formula. The sum of all terms is 72. The number of terms is 9 right here. So we divide by 9. This will give us the median, which is 8. And we know there are consecutive whole numbers. That means we go 4 terms before 8 and then 4 terms after 8. That will help us pin down the range of the 9 consecutive whole numbers. That's going to be 8, and then we go 4 before, 7, 6, 5, 4, and then we go 4 after. 9, 10, 11, 12. Altogether 9 numbers. And we are going to fill in these 9 numbers into this diagram to solve this question. So we start with the line with the least number of circles, the line with only 2 circles. There are only 2 numbers added up will give us the line of the sum of 23 from this sequence, and that's going to be 11 and 12. Whether you put 11 on top or bottom doesn't matter, right? Because if you put 11 on top, then you can put a smaller number here so that the line sum will be 23. And then you can put a slightly larger number here so that you can have the sum of 23, and a slightly smaller number here so that you can have a line sum of 23. Because for both line sum, you're adding the same number in the middle. Right? So that means we can just try, let's say, these 2 numbers. So this circle in the middle and this circle should give 23 minus 11, which is 12. So there are 2 combinations of 12 we can have. We cannot have 6, 6, but we can have 4, 8, or 5, 7. Now let's try 5. So if we have 5 over here and it's going to be 7 over here, and we know that this will be 6, but 6 is already taken. So we cannot have 6. That means we cannot have 7 over here, and we cannot have 5 over there. And what about we swap the position of 7 and 5? What if this is 7 and this is 5? And that means this will be 4, because this is 11, this is 12. If this is 5, then this should be 1 smaller, because this is 11 plus 7, which is 18, and this is 12 plus 7. Okay. Now we have 4 and 5 over here. We want this to be, sorry, before we look at this, we look at this line, this column over here. We know the line sum is 23, so that means we want this circle plus this circle to be 18. And we have used 6, we have used 11 and 12, we have used 7, used 5 and 4. So we only have 8 and 9 and 10 left. We want 17. That means we have to have 8 and 9 into these two boxes. Whether 8 goes to top or bottom, we cannot pin down yet. It depends on whether we have 4 on top or bottom. So if we have 4 on top, and that means, yeah, 9 should be at the bottom because 4 plus 9 plus 10 will be 23. And then we will have 8 on top because 8 plus 5 plus 10 will be 23. So that's how we solve this problem. This is the correct answer for this challenge question. There is another alternative correct version of the answer. So that is when you put 11 at the bottom and 12 on top. So 12, 11, and we still have 7 in the middle. This will be 5, this will be 4. We still have 10 in the middle. This will be 9, this will be 8, and then 6 in the middle. So this is an alternative correct answer. Yeah, if you that is when you swap all the numbers on top with all the numbers at the bottom. I'll just leave this over here. Okay, let's keep going to the next question. So the diagram shows the first 15 positive integers arranged in a triangle, and these numbers must be rearranged so that the 5 integers along each edge of the triangle have the same sum, unlike the example shown. So this is wrong. This is not what we want. When this is done, what is the greatest possible such sum? So we want to find the greatest line sum possible. Right, that means we only want to care on the outside of the triangle. We don't care about the 3 numbers inside. So we have the first 15 positive integers. So 15 take away 3 means that we have 12 spots we need to fill in on the outside of the triangle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Now again, let's see how many line sum are we talking about? So 1 line sum, 2 line sums, 3 line sums. So we're talking about 3K, 3 line sums, which is equal to the sum of all the numbers. So first of all, because we want the sum to be the largest, that means from 1 to 15, we're going to pick 12 numbers. We want the 12 largest numbers, as large as we can get. That means we take away the 1, the 2, and the 3. Take these 3 out since they are the smallest. Yeah, take away the smallest, what's left will be the largest. So we have 4 to 15. All right, this is the range. Pin down the range and everything else would be easy. So we want to find, so for this line sum, we're counting the 5 circles once, 1, 2, 3, 4, 5. For this line sum, we're counting the 5 circles once, 1, 2, 3, 4, 5. And then for this line sum, we're counting everything once, 1, 2, 3, 4, 5. So you see, on the 3 corners, we're counting the numbers twice. For all the other circles, we're counting them once. So that means we can find the sum of 4 to 15. Yeah, for all the numbers from 4 to 15 counted once first, 4 plus 15, applying the formula, first term plus last term times number of terms, 12 divided by 2. And then plus the 3 corners once, because we counted the 3 corners an extra time. And since we want the sum to be the largest, that means we want this, the right-hand side of the equation, to be the largest. And that means we want the 3 corners, the 3 numbers we add, to be the largest. So 15, 14, and 13. Right? So now we have the right-hand side of the equation to the maximum. And that means the K will be the maximum. This is 19 times 12 divided by 2 is 6, plus this is 29. 29 plus 13 is 42. This is 6 times 20 minus 6, which is 114, plus 42 equals to 3K. And 3K equals to 156. K equals to 156 divided by 3, which is 52. So D is the correct answer. The K, the line sum, will be 52. All right, let's keep going to question number 36. Okay, so the numbers 1, 10, 19, 28, 37, 46, and 55 are to be placed into the seventh square such that the three numbers in each of the three lines and in each of the two circles have the same sum. So again, remember the standard procedure. First of all, let's figure out how many sums are we talking about. So 1 line, 2 lines, 3 lines, and then 1 circle, 2 circles. So altogether, we're talking about 3 lines plus 2 circles. So it's going to be 5 sums, 5K. And again, and then let's figure out how many times are we counting each box. So we're counting this box by 3. This box for this line, we're counting 1, 2, 3. And then for this line, we're counting 1, 2, 3. For this line, we're counting 1, 2, 3. All right. And then for the circle, for this circle, for the inner circle, we're counting 1, 2, 3. For the outer circle, we're counting 1, 2, 3. So what have we found? We found that we counted all the boxes twice, with the center box counted 3 times. So it means an extra time. Yeah. We first consider, if we don't consider that extra time, let's say this is 1, 2, right? So we can simply find the sum of all these 7 numbers. Yeah, find the sum and then multiply by 2 because we have all the boxes counted twice. So 1 plus 10 plus 19 plus 28 plus 39 plus 28 plus 37 plus 46 plus 55. Right? And then altogether multiply by 2. And then plus an extra center box, that will be 5K. Okay? Here we need to make use of the divisibility rule. Let's first find what will be this sum, shall we? So 1 plus 10 plus 19 plus 28 plus 37 plus 46 plus 55. You can try this calculation on your own, but right now let's just save some time. This is going to be 196 in the bracket times 2 plus the center number, the center box, equals to 5 line sum. Okay, so this on the right hand side will be a multiple of 5, meaning that it will end in either 5 or 0 or 5. Okay, now 196 times 2 will give us 392, and we want this plus the center to end in 5 or 0. So we only need to focus at the units digit with the 2. So that means so if we want a 5, then the center will be 3. We'll have to end in 3. If we want a 0, the center number will have to end in 8. So we have pinned down that for this whole thing to have an integer, to have a viable line sum, we need the center box, the number to go into the center box to end in either 3 or 8. And looking at these 7 numbers, we only have one number that fulfills the requirement, and that's going to be 28. None of the other numbers end in 3 or 8. So only 28 can go into the center number, into the center square. So 28 is the correct answer. Let's keep moving to next question over here. This question is rather simple. In the 3 times 4 grid below, the sum of the numbers in each row is the same, and the sum of the numbers in each column is the same. Note that this is not the magic sum. The sum of the numbers in each column is not necessarily the same as the sum of each numbers in each row, all right? So we first look at this column. We already have the sum of this column, which is 10 plus 3 plus 2, 15. Now there is no way for us to find the sum of each row directly. So we will have to use a trick, and that is, we know that the sum of all the 12 numbers in this grid will be a constant, right? That will not change. So if we look for 4 of the column sum, yeah, that will be equivalent to the sum of all the 12 numbers, which will be equivalent to the 3 row sum. Okay, so with this, we have proved that the 4 column sum, 15 times 4, equals to 3 row sum. So that means 60 equals to 3 row sum. And that 1 row sum equals to 60 divided by 3, which is 20. Okay, with that, we can find the top right box, the top right corner, which is 20 minus 6 minus 7 minus 2. This is 15 altogether. So in the box, we will have 5. 5 goes into this box right here. And then we know for each column, the sum will be 15. So the star will be 15 take away 5 take away 1, which is 10 minus 1. So it's 9. So the value of the star is 9. Let's keep going. So question, this is the not the last question. The next question will be the last question of today's office hour. So hang on there, everyone. Question number 39. The numbers from 1 to 8 inclusive are to be placed one number to a circle in the figure shown, so that the total of the 3 numbers on each line is the same. What is the difference between A and B? So this question, again, let's have a look. If we are to count all of the circles, how many line sums do we need? So if we look at this line, yeah. So this line, and this line, they have covered all of the circles. That's going to be 3 line sums. So 3k equals to how many times are we counting each circle? Let's have a look. So 1 time, 2 times, 1, 1, 1, 1, 1, 1, 1, 1, 1. So you see, we counted all of the circles once, apart from A. We counted A twice, an extra time. So it is the sum of 1 to 8, which I will replace with the formula. So 1 plus 8 times number of terms, which is 8 divided by 2, then plus A. Okay, then let's keep going. So we have 2 unknown letters. One equation is not going to be enough. We need another equation, and that is we look for all of the line sum. Okay, this is 1 line sum, 2 line sums, 3 line sums, 4 line sums, 5 line sums. So 5k equals to, let's see, with the 5 line sum situation, how many times are we counting each number, each circle? 1, 2, 3, 4, 1, 2, 3, sorry, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So you see, we are counting all of the other circles twice, apart from the B circle. The circle B has only been counted once, so 1 less time. Okay, so 1 plus 8 times 8. Now, we do not need to divide by 2 because, sorry, we're counting all of the circles twice. So that means after we get this sum, we will have to multiply by 2, and the times 2 and divide by 2, they cancel out. So we can just leave it like this. And then we have to take away a B because in this we are assuming we counted B twice, right? B is also one of those numbers from 1 to 8 inclusive. So we have to take away a B since we only counted B once. Right, then let's have a look. So again, we have to apply the divisibility rule to pin down possible values of A and B. So for B, this will be 72 minus B equals to 5k. This should be a multiple of 5, meaning that it should end in either 0 or 5. For 72 minus B to end in 0 or 5, B can take the value 2 or 7. 72 minus something that ends in 2 will be 72 minus 2 will be 70, and 72 minus 7 will be 65. Okay, so B has the values 2 or 7. And then for A will be 3k equals to 36 plus A. Now we know that 36 is already a multiple of 3, so that means A should also be a multiple of 3, so that this whole thing is divisible by 3. So 3 or 6 are the possible values of A. Now we don't know. To find the difference between A and B, we need to know when will A be when B is 2, and when will A be when B is 7. So we will need to use the line sum. So if B equals to 2, then line sum, the 5k equals to 70 and the k equals to 14. So line sum equals to 14. And then when B equals to 7, then the line sum will equal to 5k equals to 65 and k equals to 13. So the line sum will be 13. And we just look for which value of A will give us a line sum of 14 and which of them will give us a 13, and then correspond them so that we can find the difference. So when A equals to 3, the line sum, the K, will be 3K equals to 39, which is 13. So when K equals to 13, A equals to 3. And when K equals to 14, A equals to 6. So we got it. We got our solutions. When A equals to 4, B equals to 2. Oh, sorry, it shouldn't be 4 over here. It should be 6. Right? So when A equals to 6, B equals to 2. And when B equals to 7, A equals to 3. Look for the sum, look for the difference. The difference is constant. It's 4. Okay, so 4 is the correct answer. Let's keep going to the last question for today. So well done, everyone. You've gone so far. Right, we've looked at 11 questions, including this one for this office hour. So just hang on there. Stay with me for the last question. It'll soon be over. So the numbers from 1 to 11 inclusive are to be placed one number to a circle in the figures shown, so that the total of the 3 numbers on each line is the same. Note that the three numbers on each line can include this one, this one, this one, and then vertically this one, this one, this one, and then like this, pointing in a slope, and an angle 1, 2, 3. So altogether we have 9 of these lines that we can consider. We don't need to consider all 9. Right? Now, the question is asking for the value of A. Find the value of A. And we have 11 circles altogether. So first of all, let's see what will help us cover all the 11 circles. That's going to be this line sum, and this line sum, this line sum, this line sum, and this line sum. So altogether 5 line sums. So 5K. This will equal to 1, 2, 3. So erase these. 1, 2, 3. Okay, that's this line right here. And then for this line, that's going to be 1, 2, 3. For this line, it will be 1, 2, 3. For this line, it will be 1, 2, 3. Finally, for the horizontal line, it will be 1, 2, 3. So you have found that we have counted all the other circles once, with the A circle counted 5 times. That means 4 extra times. Okay, so 4 extra times. We don't want the 4 extra times. Right, so 5K equals to the sum of 1 to 11, 1 plus 11, times the 11 terms, divide by 2. Okay, so right now we have counted all of these 11 circles once. And we need to add the 4 extra times, so plus 4A. Yeah, the 4 extra times we counted the A. Right, so that's the first equation we get. And then we need another equation, because we have 2 variables. We have 2 unknown quantities, a K and an A, right? We need to find a way to eliminate the K so that we only have A and then solve for A. It's like so this is lesson 1 stuff in the alternate term lesson, simultaneous equations. Okay, so right now we only used the vertical and the ones that are not neither vertical nor horizontal. So what I'm doing next will be the key to solve this problem, to solve this question. See if you're happy with this. So first of all, we have 1 line sum and then 2 line sums. Okay, so 2K plus 1 line sum, 2 line sums. So altogether, again, we're covering all the 11 circles. So 2K plus 2K, that's going to give us 4K. So altogether, we have 4 line sums on the left-hand side of the equation. And on the right-hand side of the equation, we have counted the circles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So for the 2 horizontal lines on top, there is no problem. For this horizontal line at the bottom and this slope, we have counted the A 1, 2, 3, and then 1, 2, 3. We have counted A 1 extra time. So that's going to be 1 plus 11 times 11 divided by 2. Again, counted all the 11 circles once, plus one extra a, not 4 extra a this time, plus 1 extra a. Okay, we have our simultaneous equation right now. We need to we need to change this. Okay, so there are multiple ways of solving this. I'll go through both ways. The first way is, because we have the same numerical part over here, we can do equation 1 minus equation 2. That will cancel out this huge chunk of number. And that will give us on the left-hand side of the equation 5k minus 4k. So it's just 1k. And then 4a minus 1a, it will be 3a. So k equals to 3a. We can replace the 5k with 3a. So 5k equals to 5 times 3a. So it's 15a. 15a equals to, we still have to calculate this, right? It's inevitable. So this is 12 times 11 divided by 2, which is 12 divided by 2. Calculate this first. 6 times 11, so it's 66. So 66 plus 4a. This is equation number 3. And then equation number 4 is 4 times 3a. 12a equals to 66 plus a. This is equation number 4. So we can solve for, we can use either equation number 3 or equation number 4 to solve for a. So 15a minus 4a equals to 66. That gives us 11a equals to 66. So a equals to 6. The answer is 6, the value of a. So this is from equation number 3. Okay. And this is the first method. The second method is you can, right, let me just get another page. Right, I have to go back, get the simultaneous equation. 5k equals to 66 plus 4a, and 4k equals to 66 plus a. So 5, change the color. 5k equals to 66 plus 4a, and 4k equals to 66 plus a. This is equation 1, this is equation 2. We can make the coefficient of k the same so that we can equate both the right-hand side of both equation 1 and equation 2. So that means we need to find the LCM of 4 and 5, and because they're co-primes, we can just, the LCM is just their product, so it's 20. So we can do 1 times 4 to give us 20k equals to 264 plus 16a. This is equation number 3, yeah, which is equation number 1 times 4, and then equation number 2 times 5 will give us 20k on the left-hand side, and then 330 plus 5a. This is equation number 4. So we can, because the left-hand side of both equations are the same, so that means the right-hand side, we can equate them. That's going to give us 264 plus 16a equals to 330 plus 5a. And then move all the a to one side and the numbers to the other, the numerical terms to the other. So 16a minus 5a equals to 330 minus 264. And the result will be the same, 11a equals to 66, a equals to 6. It will still give us the correct answer, a equals to 6. Okay, that's everything we have for today. Good job, everyone, for hanging up with me.